Lastly, let's consider a MU-A741 op-amp. We want to determine the output of our VCVS using the finite gain model, and that using the finite gain model with CMRR. To begin, the output of our finite gain model is given as A times V2 less V1, where our gain typically associated with this operational amplifier is 200 volts per millivolt times V2 less V1. Thus, we have a value of 200,000 times a quantity V2 less V1. Thus, considering CMRR, our output of our VCVS now becomes A times the quantity, the subquantity 1 plus 1 per 2 CMRR times V2, less the subquantity 1 minus 1 per 2 CMRR times V1. Now, if we take our CMRR value of our MU-A741 op-amp, we see the output of our VCVS is equal to 200,003.2 V2 less 199,906.8 V1, a marginal difference. We've seen by increasing the fidelity of our modeling to represent our non-zero bias current, our non-zero offset voltage, our finite input and output resistance, that our values don't drastically change from our idealized model. And thus you should determine when to use these high fidelity models and if they will make an impact on your analysis.